Hello student, how are you? I am Arun Sir, qualification Bachelor of Engineering from Jadavpur University. Welcome to my channel Tuition Expert. Today in this class I will teach you about the relative velocity. Now let's start about the relative velocity. Suppose two cars moves, car A moves with velocity VA and another car moves with velocity VB along same direction. Relative velocity is a vector quantity. So VAB has defined VAB. VAB means relative velocity of car A with respect to, this is called with respect to, of car B. Here we study as in this form: relative velocity of car A with respect to car B equal to VA minus VB. This is the definition of VAB. We study VAB as this relative velocity of car A, first car A with respect to B, second term with respect to. So this is called VA minus VB. This is the definition. Now suppose the direction along this is I and magnitude of VA is VA. So this is written as VA I minus VB I. Okay, vector quantity. So this is VA minus VB I. So when two body moves along same direction, then their actual velocity with respect to one will be difference of their velocity. Magnitude will be difference of the velocity. Now what is the magnitude of this? This equal to VA minus VB. So if two cars moves with same direction, then velocity of one with respect to other will be difference of their velocity. Car moves with velocity v in this direction and car B moves with velocity in this direction. So now what's about VAB? VAB is VA minus VB. This is actual definition. We always write in this form: VA minus VB. Now put here vector VA I minus VB. VB vector will be minus VBI because VB moves in the opposite direction of x-axis. So here vector will be minus I. Magnitude of this. So what happens if two cars move in opposite direction? Then velocity of one with respect to other will be the addition of magnitude of their velocity. That is, velocity will be increases. So it seems to move with increased velocity if two cars moves in opposite direction. So velocity will be addition of magnitude of two velocity. Rain man problem. Man moves with velocity Vm in this direction and rain falls vertically. This now what will be the direction of the rain with respect to man? That is, at which direction man see that rain comes to him, at which direction. So we define velocity of rain with respect to man. Now we observe that the velocity of rain with respect to man. Man want to observe the velocity of rain when he moves with some velocity. So Vrm equal to Vr minus Vm. This is actual definition. Now if we denote the unit vector along this direction I and this direction vertically downward, that's k. Here road, two roads are at an angle theta. One car moves along this road with velocity Va and another car moves with velocity Vb along this direction. Angle between two roads is theta. Now if if a man at the car A observe the car B, then what will be its direction? The direction will be, so we want to calculate velocity of B with respect to A. So we can write VB minus VA. Okay. If a man at car A observe the car B, then what will be its direction? So this is the relative velocity. Like if a man stands at the ground at rest, observe the velocity of car B, then car moves along this direction. But if a man situated in the car A observe the observe this car, then the direction of the car will be different. So the direction will be get from this direction VB minus VA, which is called VB plus or minus VA. Now what is VA? VA, we reverse the velocity of car A. Now this is theta, so this angle is pi minus theta. Now this is VA, this is VB. So what is the direction of VAB? Direction of VAB, VA equal to this plus this. So if we draw that parallelogram, then the direction will be this. So this is VBA. This is VBA, direction VBA. So magnitude of VBA will be root over VB square plus VA square plus 2 VB into VA cos angle. Angle is pi minus theta. Cos theta. So this is the magnitude. Now what will be the direction? Direction is this. Direction is this. So this angle is alpha. We get tan alpha equal to, from law of parallelogram, VB sin angle is pi minus theta. Angle is sin pi minus theta divided by VA plus VB cos pi minus theta. So from this relation we get angle alpha. So if we get angle alpha, then we get the direction of VBA. So this formula comes from this, from the law of parallelogram. Suppose this is vector A, this is vector B, angle is theta. Then what is the direction of alpha? From, we know that formula is B sin theta divided by A plus B cos theta. Two shifts A and B are 10 meter apart on a line running south to north. Ship A further north is streaming west at 20 km/h, and CP is streaming north at 20 km/h. What is their distance of closest approach, and how long do they take to reach it? Is the question. Two ships A and B are 10 meters apart. The problem is this: two ships, two ships A and B are 10 meters apart on a line running south to north. Ship A further north is steaming west at 20 km per hour, and ship B is steaming north at 20 km per hour. What is their distance of closest approach, and how long do they take to reach it? This is the problem. Now to understand the problem, you need a diagram. Suppose this is east direction, this is north, south, this is west. So car B, suppose is at here, and car A is at here. The distance between two car is 10 meter. One car, two car on a line running south to north. CB further north, further CB further north is steaming west at 20. So CA is moving towards west. So this is the velocity of CBA, and CB is steaming north, and this moves with velocity, not with same velocity, but it is moving with this direction north. So CB is moving towards north direction, and CA is moving towards west direction. This moves along this line, and this moves along this line. So what will be their closest distance? Suppose car A is at here, car B is at here. The distance will be this. Suppose car, sorry, suppose ship A is at here and ship B is at here. So distance between them is this. Suppose ship A is at here and ship B is at here. Now the distance is this. Now which will be the closest distance? Which will be the closest distance? We have to find it. So to solve the problem, first find VBA. VBA equal to VB minus BA. VBA, VB minus BA. VB, suppose this is J vector, unit vector along this J, and unit vector along this is I. So this is 20I minus VBA. VBA is actually minus 20I. That is, VBA is actually 20J, and this is this. So 20 magnitude of this equal to this. So VBA direction, magnitude of VBA is this. Now to find the closest distance, we apply the technique. Suppose ship A is at rest, and the direction of VBA is along this. VBA equal to VB minus BA, which is equal to 20J minus 20I. So direction of VBA will be VBA equal to VB minus BA, that is plus plus. So direction will be along 45 degree, because tan theta, if this angle is theta, then tan theta equal to perpendicular, this is perpendicular, this is base, 20 by 20, 1, that is theta equal to 45 degree. So VBA, the direction of VBA is along 45 degree with horizontal. Now to find the closest distance, to find the closest distance, we take the CB is at here, that is CB is at rest, and VBA, the direction is this. So the perpendicular distance from this to this is the closest distance. Perpendicular distance. So this is the closest distance in 45 degree. This angle is 45 degree. So this is the distance D, and this is the length 10. So sine 45 degree equal to perpendicular by hypotenuse. So D equal to 10 This is the answer. So closest distance will be this. Now how long it take to find this? Now what is the distance? This distance, this distance will be yes cos 45 degree equal to base by hypotenuse. So x equal to 10 by root 2. So this is the distance x. Now how long time? That is time equal to distance by velocity 10 by root 2 with velocity kb. VAB, what is VAB? VAB will be 20 into root 2 1 by 4 hour, that is 15 minutes, because 20 kilometer per hour. So hour, this is the time in hour unit. 1 by 4 hour means 15 minutes. An aircraft flies at 400 kilometer per hour in still air. A wind of 200 per hour is blowing from the south, blowing from the south. The pilot wishes to leave, wishes to travel from A to point B north, east of A. Find the direction. He must and he must steer and time of his journey. If AB equal to kilometer. The problem is an aircraft flies at 400 kilometer per hour in still air. A wind of in still air. A wind of 200 kilometer per hour is blowing from the south. The pilot wishes to travel from A to point B, not east of A. Find the direction he must steer and time of his journey. He may be distance AB equal to 1000. To solve that problem, we need a diagram. Suppose this is east, this is north. The aeroplanes start from the point A and he wishes to move at the point B along northeast direction. That is, direction will be 45 degree. We know north east direction is 45 degree with east direction, and wind is blowing with this. So actually this is VW. Given AB, distance AB equal to 1000 kilometer, VW velocity of wind equal to velocity of wind equal to this along this direction velocity of wind and given velocity of aircraft is velocity of aircraft VA and this is VAW. We know VAW plus VW equal to VA. So we can here apply the triangle VAW plus VW equal to VA because VAW one means VA minus VW. This is actually VA minus VW plus VW which is cancelled, that is VA. So from the triangle we can also say that this plus this equal to this. Now given velocity of aircraft equal to 400 kilometer per hour. Now this angle is 45 degree, we know northeast direction. So this angle is 45 degree and this 45 degree. Suppose we have to calculate this angle alpha. If we calculate angle alpha, then we get alpha plus 45 degree, which will be the direction of the aeroplane. So to find the alpha, we can use triangle rule. A, this is the point C. Suppose from the triangle ACB, apply triangle rule. This by this, this by this. AC is actual velocity of the aircraft with respect to VAW. This is actually VAW. VAW means actually this is VAW. This is VAW. So VAW is 400 degrees. So applying sine rule, we get this by this equal to this by this, this by this, this by this opposite angle this. So this by this equal to this by this. That is VAW equal to VW equal to 200 root 2. So sin alpha equal to root 2 sin alpha equal to sin 45 degree 1 by root 2. That is sin alpha equal to half, which is equal to sin 30. That is alpha equal to 30 degree. Alpha equal to 30 degree. So we get the angle alpha equal to 30 degree. Now we calculate, we can get this angle, that is 30 plus 45, 75 degree. So the aircraft should steer at the angle 75 degree from its direction, 75 degree from this direction. So answer is 75 degree from east. So we can say that also 75 degree north of east, north of east. Now to find the value of VA and time taken, we first find the VA, velocity of A, velocity, actual velocity of A, velocity of A with respect to wind. That is when wind is zero velocity, then this is the velocity of aircraft. Now in the presence of wind and velocity of aircraft, the result velocity is VA. So what is the so time taken, to find the time taken, this will be actually the distance by velocity VA. Now we have to calculate VA. We have to calculate VA. So now from the triangle This is 30, this is 40, this is 30 degree, we get this is 30 degree. Now from the triangle ACB again, DA by sine, this is 45, this is 30. So this angle will be 180 minus 45 plus 30, 105 equal to VW by this. So VA will be cos 15 degree, cos 15 degree equal to cos 45 minus 30 degree. We get a value of cos this. So we get the value of VA. Now what is the time taken? Time taken T equal to distance by velocity, distance AB by velocity VA, which is called, which is VA equal to this. So this will be actually, so this root 2 cancel, 2 200, 200, this is actually 5. So 5 by, this is 5 by root 3 plus 1. So this is the answer, time taken. Problem 3. To a man walking at a rate of 3 km per hour, the rain appears. The rain appears to fall vertically. Okay. To a man walking at a rate of 3 km per hour, the rain appears to fall vertically. When he increases his speed to 6 km per hour, it appears to meet him at an angle of 45 degree with vertical. Find the speed of the rain. Now I repeat this problem once again. A man walking at a rate of 3 km per hour, the rain appears to fall vertically. When he increases his speed to 6 km per hour, it appears to meet him at an angle of 45 degree with vertical. Find the speed of rain. So this direction is J and this direction is I. This is horizontal, this is vertical. Horizontal, this is vertical. Now here the problem, we don't know what is the velocity actual velocity of rain. We don't know. Uh, the relative velocity is given. Relative velocity of rain is given, but we don't know the actual velocity of rain. So solution: if we draw the problem, if we draw diagram now if we want to draw the diagram, then it will take time. So let the we don't know the actual velocity of rain, so we assume that velocity of rain, let the velocity of rain is let the velocity of rain is this ai plus this unknown value. Now giving velocity of rain, magnitude of velocity of rain will be this, you know. First case, velocity of man, in first case velocity of man equal to along horizontal, so we take vi. So velocity of rain with respect to man, velocity of rain with respect to man will be, we know, vr minus vm. We know vrm equal to vr minus vm, so vr equal to this minus vm equal to 3i. So this becomes this, so this becomes this. Now it seems to be in vertical direction, it seems to be in vertical direction. So if the velocity, if this direction of the velocity is be vertical, then this component must be 0. So a minus 3 equal to 0. From from this we get a equal to 3. Now in second case velocity of man now 6i, and now vrm will be va minus vr minus vm, which is equal to this. So this becomes, it is 45 degree. It seems the direction of this seems to be 45 degree with vertical. So we get tan 45 degree equal to perpendicular by base b by a minus 6, that is b equal to a minus 6. So h, magnitude of this, we take this b equal to this. Now the value of h 3, so this becomes 3. So b equal to 3. So velocity of rain becomes, so we get a equal to 3 and b equal to 3. So now we get the velocity of rain, a magnitude of velocity of rain equal to root over a square plus b square, which is equal to kilometer per hour, 3 root 2 kilometer per hour. So this is the end of the class of relative velocity of part 1. In part 2 I will discuss the river boat problem and more problem related to relative velocity. Okay, thank you.